And now that's a pleasure. I would like to invite Dafna. Okay, you will present your second family name by yourself. Dafna is from Israel. Just say a few words.
Sure. Very long and difficult names. Dafna Gewirtzman from the Faculty of Architecture at the Technion. It's Israel Institute of Technology. It's a technical university. And we have the largest Faculty of Architecture there, and a lot of students, undergraduates, and a lot of graduates too. So I am going to talk about, actually it's very exciting for me to be here, since my major teaching in the school is adaptive reuse design studio for architecture students. So being here, it's like, you know, going to the right place to see how these adaptive reuse projects are lively, and I mean, here in the geographic, well, we heard this how do you say? Well, anyway, I'll go on. My research is about visibility, and I'm going to talk about current automatic tool that we're working on, a 3D line of sight visibility analysis model, which is trying to automatically quantify and the qualitative and quantitative aspects of urban environment. And of course, what we want is healthy and sustainable cities for very happy and content people. And maybe even more happy. So I'll give a very short introduction, some research background, very, very short, and introduce our case study and show you some analysis and, of course, conclusion discussions. So the introduction is going to be very, very short, since everybody's here because you all believe that our vision is one of the most important abilities of human abilities to actually perceive and understand environment, and we're living through, of course, all our senses, but visibility is very strong. And of course, the 3D representation of the built environment and the analysis must be part of a 3D reality. So there are a lot of visibility analysis models that have been developed for the past, I think, quite a few years. 1979 by Benedict the Isovist is quite old, but you see that there are some point-based visibility graphs, Isovist and Isovist fields, automated Isovist measurements and tools, automated 3D visual analysis regarding human perception in space, and the complexity of course, and the accuracy in computer and 3D visual analysis must be also mentioned, since this is probably the most important problem to be solved when you want everybody to actually be a user and not to be a technical person. It must be very, very easy to use. So what I started my way by trying to go into some kind of an attempt to measure the perceived density, which is, of course, is a qualitative, it's something which is very subjective. So how come I tried to measure it? So what I did in my PhD back, well, I never tell you when, but it was to try and see if there is a correlation, and I found a very nice correlation between the volume of visible space and the reaction to it when you ask people, how dense do you feel? What is your perceived density? So the spatial openness index, what I called it then, which measures the volume of space, the higher the value of the SOI indicates a lower perceived density. Since then, we have a voxel-based 3D visibility and analysis together with Shashkov and Deutscher, which is the current SOI measurement. You can also read some papers about that. And what we're also trying to do is see how is the scenery influencing people, the perception and cognition of people. And this is just one example when we try to put people inside an augmented reality and ask them about how they feel about the view that they're looking outside. And also we measured, since these were real views, so we could actually measure how much open space we could measure. And we also got very nice tendencies with the correlations. I'm sorry, I'm stepping over you, sorry. So the current loss-based 3D visibility analysis that is currently being developed with Elber, the computer science faculty at the Technion, it is a model that you can actually put insert. Oh, I'm sorry, I thought I was pointing. Yeah, right. No. I wanted to, put the laser. Do you have a? In the middle. Oh, okay. Oh, now it's. So what do I do now? Okay. Okay. So you can insert 3D SketchUp models. Every architecture student knows SketchUp. It's a free SketchUp Google software in the internet. You can create these environments, physical, realistic and virtual realities, and you can insert them inside, and then we can we analyze actually the view from, for instance, from this internal space in the room, looking out, and it's actually pointing out something like 640,000 rays, lines of sight outside, and the outcome is a depth view. This is not a very good depth view, but the red are the very short lines of sight that this person has around his window. It's a very short. It's just from his eyes to the wall, and the green. It's as it goes back and goes further away. You see some buildings from his window, and of course the sky. So it's not the real sky, but it's it represents the length. So I'm going to jump to the objective and then show you the case study. So what we wanted was an automated 3D visibility analysis model that enables integrative quantitative and qualitative visual analysis. We believe this is what influences human perception. And of course, we use the GIS as basic and very important data. So we have a student, one of 100, that we use in a bigger study. Each student that live in an apartment, their apartment was the layout of the apartment and the functions in the apartment were indicated, and of course also the view from each window in the apartment. So what we did was analyze the volume of visible space from each window from each room in that apartment. And we asked these students, so that was the objective part of it. We asked these students, are you content? Do you like your apartment? But also we asked them, these were like open questions. And we also asked them questionnaires about their perceived density, about their privacy, do they like the view, what kind of view do they have, and so forth. So this student was the one that made me think that we need to do something more, not else, but more than just measure the volume of visible space and the distances to various objects in the space, because there was wonderful correlation in what we measured and what he said. from what we learned was that he was having a very low perceived density. He had a lot of privacy, visual privacy. Nobody could actually see him inside his room or his study. He had a lot of privacy. He loved the scenery. I don't know if it's not very good pictures, but he can see the Haifa Bay, which is beautiful. When he didn't see the Haifa Bay, he saw beautiful trees. So everything was wonderful. So then, when we asked him, "Are you satisfied with your apartment?" he said no. He was completely, wrong regarding my statistics. So then I looked, why? And he said, because a close-by school is a big disruption. Of course, but of course when it's an architecture student that lives actually like in a, he works all night and he skips school because he wants to sleep in the morning, and then the school kids, and it's a lot of noise, but what if it was a young couple with 2 kids? This was great if they had a school. 5 minutes or 5 seconds? Yeah, okay, so I'm fine. Okay, so that's when I went back to GIS and incorporated into our analysis only 2 things. The land use map, some data about land use, and I'm sorry, that's Hebrew, if you're trying to read, and some orthophoto with vegetation. And then we represented this information in colors or also in funny trees. Of course, this is not the realistic trees. So, and then we went back again to the analysis, to the depth view, but we incorporated the idea of, we had different colors for topography, large trees, roads, dwelling, public buildings, sky and distant view, current buildings, and so forth. Current building is the building that you're actually looking from where the student's actually living. So first step was to get the full depth views for each window. Also, we have the terrace, doesn't matter. And then I asked my computer science student, she's actually working on the software, to separate each element in the depth view. So you see, this is the internal wall around the window. So there's quite a large percentage of rays that are into the wall. So what is interesting is more the size of the window. Because if we have a very small window, then of course it changes. But also I didn't want to get into it because it also depends on where you stand in the space. If it's very close to the window, then of course it doesn't matter if it's a very small window. Anyway, so this is where you see the other buildings around, the trees, the sky and distant view, and in this case there are no public building, commercial space, roads, and topography. So now going back to our unsatisfied student, from his study, this is actually the stage 1, where you can see a depth map of the whole view. But then when you separate it, and you get down to the public buildings, you see that there are some things that were colored in red in the original, what you saw before. Here, this is the school. And what he sees is just a little bit of this, which is like the cover. In Israel, you have to put a cover on top of every schoolyard so that the children don't get either wet or very hot from the sun. So this is what he sees, and this means a lot of noise, a lot of hours of the day. So probably if we had known that, and if we had taken that into account, we could indicate that this person, if he is a student, he might be very, very, he would be negatively regarding his apartment. And perhaps then somebody could say to him, you know, this is a beautiful apartment with a beautiful view, a lot of privacy, but please don't take this because you will suffer from the school. Or if you were, so what do we actually need? And going back to, proceeding with my conclusions, perhaps if we had also layers of information about the profile of people that are using, and we incorporate that in our analysis, then that would be much, much easier for people using these apartments, and also for predicting how people will actually feel and react in different environments. So this is an attempt to combine qualitative and quantitative attributes in one automated tool. It's just the first step, and we hope to that this will bring us closer to represent and perhaps predict the human perception in such environments, built environments. Of course, GIS is the data infrastructure for the analysis. It is a very easy to use. I hope very soon it could be on the web, especially for our students, and then we'll try to release it for everybody to use, to get some kind of data and information about, their design, especially architects and perhaps urban designers. Outcomes may be well accepted back as another layer of GIS. And we hope to calibrate the model with human response, and here you can see some view from one of our visualization labs. Maybe just, one small example that this is a commercial street in that same neighborhood. You see that this is the first floor, the streets level is commercial, and then there are some people living upstairs. So we could analyze what is this person actually seeing. And you can see that he can see, he can see the commercial space, he can see the road, and of course then we can divide it into different roads, and to see, if you don't like busy roads, then you shouldn't live there, and so forth. And so this is like separating and getting a lot of data in a much more comprehensive way. Thank you very much.
Thank you, Dafna. Thank you. Keep your questions for Dafna. And I liked very much that you proposed to have a new GIS layer related to the human preferences or individual preferences. That's interesting, I have to say.